Hello boys and girls, it's Mr. Landry. Today we're going to continue our study of trigonometry. We're looking at two triangles that you should know. You should know at the end of the lesson. The 30-60-90 and the 45-45-90. You'll see why in a few minutes. Okay? Let's begin by looking at an equilateral triangle. An equilateral triangle means that all three sides are equal. Now let's say I measured them and they were 2 inches each. Now since it's equilateral, not only are the three sides equal, but the three angles are equal. And if three angles in a triangle are equal, they're each 60, so that they total 180. I'm going to take this triangle and I'm going to split it by dropping a perpendicular line here. Now because this triangle is isosceles, an equilateral triangle is isosceles, that perpendicular, in addition to making the 90-degree angle, does a couple of other things. It cuts the bottom in half so that it's 1 and 1, and it cuts the 60-degree angle in half so that it's a 30 and 30. By dropping that perpendicular line, you've created two 30, 60, 90 right triangles, two of them. I'm going to redraw this one over here. Let's see, there was a 60 here, a 30 here, this was 2, and this was 1. Now let's find the missing side by using Pythagorean theorem. X squared plus 1 squared is equal to the hypotenuse squared, which is 2. X squared plus 1 equals 4. Let's get the x alone. X squared is equal to 3, and so x would be the square root of 3. Okay, so here's your 30, 60, 90 triangle. The 60's down here, think of the heavier angle down here. The 30's up here, and 2, 1, square root of 3. I always remember that the square root of 3 was next to the 30. 3, 3. Okay? And the reason I'm stressing that is because you should memorize that. When you sit down to take a trig exam or do your trig homework, remember from the first lesson, the first thing you should write is the acronym SOHCAHTOA. And the second thing is you should draw this triangle, the 30, 60, 90. The reason is because now, without a calculator, you can find the sine of 30, the cosine of 30, or the tangent of 30. Here's your 30-degree angle. The sine of 30, the opposite over the hypotenuse. Here I am at 30. Opposite, the side that doesn't touch me, 1. Over the hypotenuse, 2. The sine of 30 is a half. Check it with your calculator. Cosine of 30. Here I am at 30. That would be the adjacent over the hypotenuse. Adjacent, the side that touches the 30. Square root of 3. Over the hypotenuse, 2. And tangent of 30. The opposite, 1. Over the hypotenuse, square root of, over the adjacent, square root of 3. There, without a calculator, I have the sine, cosine, and tangent of 30 degrees from memorizing this triangle. I also have 60. Sine of 60, cosine of 60, tangent of 60. Sine of 60. Sine, opposite. Here I am at 60 now. Opposite, the side that doesn't touch the 60, square root of 3, over the hypotenuse, 2. Cosine of 60, the side that touches the 60, right here, 1, over the hypotenuse, 2. Tangent of 60, opposite, over the adjacent, square root of 3, over the adjacent to 61. And you know if anything is over 1, you don't have to write the over 1. You could just say the tangent of 60 is the square root of 3. Kids, now you know the sine, cosine, and tangent of 30 and 60. And you're required to know these, okay, without a calculator. And there they are, okay, just from knowing that triangle. Again, when you sit down to take your trig exam, write the acronym SOHCAHTOA and draw this 30, 60, 90 right triangle. 2, 1, square root of 3. Remember, the square root of 3 is next to the 30. And the 2 is the hypotenuse. 60 is down here on the bottom. Heavier angle on the bottom. Okay? They might say, well, that's that equilateral triangle. What if I had a bigger one? A little hard for me to draw a bigger one, but let's say I had an equilateral triangle that was 10 inches on each side. Still equilateral, so the angles would still be 60, 60, and 60. I could still drop the perpendicular, and the bottom would still get cut in half, and the angle. In this case, I'd have 2 of these triangles, a 10, a 5, a 60 down here, and a 30 here. Now let's find the missing side by Pythagorean theorem. X squared plus 5 squared equals 10 squared. X squared plus 25 equals 100. Minus 25 on both sides. X squared equals 75. X is the square root of 75. All right, so this side here is the square root of 75. Well, if someone were to ask me here, what's the cosine of 30? I would say it's the adjacent, square root of 75, over the hypotenuse, 10. Yet here the cosine of 30 was the square root of 3 over 2. They're different. Or are they? Let's see what the square root of 3 divided by 2 equals. Second square root of 3, move over so you're out of the box, divided by 2. It's 0.8660. Let's see what the square root of 75 divided by 10 is. Second square root of 75, let's move out of the square root box by going across, divided by 10. Oh, it's the same thing. Guys, if it's a 60-degree angle, the cosine, I'm sorry, if it's a 30-degree angle, the cosine of 30 is going to be 0.8660. The ratio is always the same for the same angle. That's the importance of trig. Whether it's a small triangle or a triangle as big as a mountain, if the angle is 60, then the cosine is going to be 0.8660. And that's not just true for the 60. It's true for every angle. Every angle's sine, cosine, and tangent is going to be the same, no matter how big or how small the triangle is. Okay, and we'll see the importance of that in doing some problems tomorrow. But for now, remember when you take a trig exam, write the word SOHCAHTOA and draw this triangle. 2, 1.